Okay, let's dive right into this explainer. Today, we're exploring a really fascinating intersection where intense power systems engineering collides with extreme electricity market economics. It's a topic that absolutely captivates engineers, researchers, and financial traders alike. What we are going to do here is analyze 100% market price dynamics, looking at how an entire massive grid operates under absolute, pure free market conditions. To really wrap our heads around this, we kind of have to forget about normal grids where a central authority tightly controls everything. We are looking at a total outlier.
So what actually happens when a grid completely isolates itself and just lets the market take the wheel? Well, the ultimate real-world laboratory for this is the Texas electrical grid, officially known as ERCOT. Now, when we say isolates itself, we aren't just talking about drawing a border around some transmission towers. We're talking about the creation of a completely unique ecosystem, one that relies entirely on pure supply and demand to keep the lights on for millions of people. It's this incredible story of physics meeting economics in real time, with absolutely no safety net.
Let's start with part one, the architecture of isolation, and specifically how they managed to avoid the Federal Power Act. Because to really understand the economics here, you have to understand the physical anomaly of this isolated grid. You literally can't separate the market design from how this thing was legally and historically built.
It was actually a highly deliberate four-step play. Step one, a conscious decision to avoid the Federal Power Act. Back in the early 20th century, federal rules started dictating how utilities could trade and price power across state lines. Well, Texan utilities basically said, no thanks, we'll keep control of our own business. By intentionally ensuring their power lines never crossed state borders, they structurally isolated themselves, sidestepping federal oversight entirely. That led straight to step two, establishing their own independent legal foundations. Step three was the official birth of ERCOT as the regulatory body. And step four, this is the crazy part, they had to engineer a fully isolated synchronous grid to pull it off. This physical island of electricity is the absolute bedrock of everything we're about to talk about.
Moving on to part two, energy-only market dynamics. Since Texas cut itself off physically to avoid federal rules, they couldn't just lean on their neighbors for backup power in a pinch. So they had to design a completely custom economic engine to guarantee power generation and keep the grid from collapsing.
So they went with what's called an energy-only market. What this means is generators are paid exclusively for the electricity they actively push onto the grid, period. There are no fixed payments just for sitting on standby. Instead, the whole system relies on massive, sudden price spikes to incentivize power plants to turn on. I mean, imagine a power plant sitting idle, bleeding money for months, only to make its entire yearly revenue in a few frantic hours of intense summer heat when prices just go astronomical. The main takeaway here is that high-frequency market operations totally replace standard regulatory safety nets. The market is the only safety net.
To really put this into perspective, let's compare it to a standard market. In a standard regulatory market, you have central capacity planning. The grid basically pays power plants just to exist and be ready, like an insurance policy. But on the ERCOT side, it's energy only. You only get paid for active power, and you heavily rely on scarcity pricing to survive. By choosing this route, Texas committed to an environment where price, and literally price alone, dictates grid reliability.
All right, part three, high-frequency real-time pricing. Let's look at how scarcity and the ORDC actually work minute by minute, because it is a constant, incredibly high-stakes balancing act where supply has to perfectly match demand every single second of the day. 100%. Let that sink in. In this system, exactly 100% of reserve procurement and frequency control is managed purely through these real-time market prices. In other grids, a central dispatcher will literally pick up the phone and order a plant to turn on during an emergency. Not in Texas. There is no central boss commanding the grid. Instead, the system just waves cash. It raises the price higher and higher until it becomes incredibly, undeniably profitable for someone out there to fire up a generator and provide power. The engine behind this is the ORDC, the Operating Reserve Demand Curve. You can think of the ORDC as the invisible hand of the grid, but on steroids. It's a high-frequency pricing mechanism that automatically and dramatically hikes up prices the second grid reserves drop dangerously low. It's quite literally an automated panic button, and it uses cold, hard cash as the alarm bell. You can really see the ORDC magic, or madness depending on how you look at it, right here. When grid reserves are high, prices are chill. Standard operation. But watch what happens as reserves start dropping. Scarcity pricing is triggered. The market signal basically screams, start generating right now. And if reserves hit critically low levels, the ORDC maxes out at the absolute price cap. We are talking prices skyrocketing from maybe double digits to thousands of dollars per megawatt hour. The financial incentive to keep the lights on is massive and immediate. And the people actually pulling the levers, those are the qualified scheduling entities, or QSEs. These are highly specialized trading organizations navigating this volatility on the ground. Think about the intense human pressure here. These traders are watching complex price graphs every single second, predicting weather, and executing high-frequency trades while prices are swinging wildly. Fortunes are literally made or lost in minutes, depending on how these QSEs react to a sudden drop in grid frequency.
Which brings us to part 4, the ultimate stress test. Winter Storm Uri. What happens to a pure pricing mechanism when the underlying physical engineering faces catastrophic weather?
Winter Storm Uri was a visceral, devastating reality check. Day 1, severe freezing weather hits a grid built for extreme heat, not extreme cold. Day 2, we see an unprecedented demand spike. Millions of people blasting their heaters just to survive. By day 3, you get cascading grid failures. The natural gas wellheads, the wind turbines, the coal piles, they literally froze solid. And day 4, extreme scarcity pricing was maintained for an agonizingly long time. The crazy thing is, the ORDC worked exactly as it was mathematically designed to. It kept prices at the absolute maximum cap, but the physical plants were just too frozen to respond to the cash. It was this tragic collision between perfect economic theory and failing physical reality.
So, where do we go from here? Part 5, Future Reforms and Reliability. Looking past the trauma of Uri, this isolated ecosystem is now being forced to adapt to entirely new realities.
Because, guys, the grid is facing a whole new set of beasts today. We're seeing an exponential draw from AI data centers and massive loads from Bitcoin miners who love the deregulated market. But here's the rub. They demand flat 24/7 power, which heavily conflicts with wild price swings and the variable nature of wind and solar. Add in the rapidly shifting economics of battery storage, and you've got an incredibly complex puzzle. Huge, inflexible power demands are now constantly interacting with high-frequency, real-time pricing. It's really testing the limits of the energy-only model.
To try and manage this, we're seeing some major regulatory developments approaching in 2026. One fascinating initiative is Project Connecting Texas. They're looking at using DC ties, direct current connections, to slightly bridge that historical isolation. It's a brilliant engineering workaround, really. It allows them to pull emergency backup power from neighboring grids without fully synchronizing their systems, which keeps them out of standard federal jurisdiction. They're basically cracking open the architecture of isolation just a tiny bit. So, the ultimate question we have to leave you with is this. As the whole world rapidly electrifies, is ERCOT's 100% energy-only market a cautionary tale? Or is it actually the blueprint for the future? By stepping back to deeply analyze 100% market price dynamics, we see the ruthless, incredible efficiency of scarcity pricing, but we also see the devastating risks when physical machines simply can't answer the market's call. Whether it's through giant batteries or clever new DC ties, the evolution of the Texas grid offers some profound lessons for electricity markets everywhere. Thanks for diving into this explainer with me. Keep questioning how the invisible hand of the market powers the very visible lights in your home. Catch you next time.